All right, let's try an area practice problem. And for this one, they're not telling us whether we need to integrate with respect to x or y. So I think it's up to us to decide what works best for us. So if I were to first draw a graph, and of course we now know that the ln of x plus 1 looks like this. And we know that y equals 1 looks like this. It's not a very good graph, but that's okay. And then the interval is now from 0 to 2.5. So let me change colors so we can get a good visual here. 0 to 2.5 on the x-axis. 0 starts here, and then 2.5 is going to be over here. So I have two distinct regions. And I think what will be easiest is just to leave it in terms of x and do top minus bottom. But of course my top and bottom curves change right here, so I need two different integrals. The first integral is from 0 to e minus 1 of the ln of 1 minus the ln of x plus 1, because it is top curve minus bottom curve. Top curve here is 1, bottom curve is the natural log of x plus 1. This is the exact same thing that we just did on the prior page in method 1, and what we got here was approximately 0.718. So this is region 1, shall we call it, which would be right here. We'll call that region 1. So now I need to do region 2. And the difference here between region 1 and region 2 is that the top curve and the bottom curve have changed. So now the top curve is the ln of x plus 1, and the bottom curve is y equals 1. So I'm subtracting that out. I have top minus bottom here. And my limits of integration, I start at e minus 1, which was that x value of the intersection point, and I'm going to go over to my right-hand limit of integration that's given to us of 2.5. Now again, you're going to put this into your calculator to determine the value, and in the end, you're going to get the sum of these two values as 0.821. So now let's go ahead and try another example. We are going to have two methods again, and let's recall that our method 1 is always going to be with respect to the x-axis here, and our method 2 is going to be with respect to the y-axis. And again, we have our old standby curve, the natural log of x plus 1, and in this case we have the line, the horizontal line, y equals 1. We'll draw it in for both graphs, and then the vertical line, x equals negative 1/2. So let's see what that does to the work that we do. First method is x-axis, so we're going to have vertical orientation of our integral here, so I put in my vertical line segments. Second method is going to be y-axis, so I'll put in these horizontal line segments to evoke the right minus left. So let's recall that we need top minus bottom when we do the x-axis. And let's recall that we do right curve minus left curve when we do the y-axis. So the x-axis here, we start with the top curve, which is the y equals 1 curve. And then the bottom curve, oops, don't need a comma, need a subtraction sign, sorry about that. The bottom curve is going to be the ln of x plus 1 throughout the entire interval. So the setup looks fairly easy from figuring out the top minus the bottom curve. We just need to know the limits of integration. Well, the left-hand limit of integration here is going to be x equals negative 1/2, so that's my lower limit of integration. And of course, the intersection point between these two curves we've already found to be e minus 1. So what you're going to do is put this in your calculator and evaluate, and you're going to get approximately 1.3717. So you can provide 1.371 or 1.372 as your response. Now let's look at right curve minus left curve. The first thing that we need, again, is to write ln of x plus 1 in terms of y, which if we go back to what we had on a prior page, we can find out what that was. That is x equals e to the y minus 1. So that is going to be our right curve here because it is the right-hand side of the enclosed interval. So if I start my integral, I take the right curve, e to the y minus 1, and then I need to subtract out my left curve and have a dy. In this case, my left curve is this vertical line x equals -1/2. So -1/2 is my left curve, and I have right minus left. Now my limits of integration, my upper limit of integration is fairly straightforward. It's y equals 1. But for my lower limit of integration, I need to find where x equals -1/2 is equal to e to the y minus 1. Now that is going to take a little bit of math to figure out, but that's okay. I can add 1 to both sides to get 1/2 equals e to the y, and then I can take the natural log of both sides, and I get ln of 1/2 equals y. So my lower limit of integration is going to be the natural log of 1/2. And guess what? When I put this into my calculator, I get out the exact same answer as 1.3717, which again, you can truncate or round.